Have you ever pondered over the fascinating ability we possess to make accurate predictions about a population from just a small sample? This ability, central to our understanding of statistics, owes its existence to a fundamental statistical principle known as the central limit theorem. The central limit theorem, or CLT, is a statistical theory with profound implications. It posits that if we repeatedly draw independent and identically distributed samples from a population and calculate the mean of each sample, the distribution of these sample means will converge to a normal distribution as the sample size increases. And here is the magic. This convergence happens regardless of the original population's distribution, even if it's skewed or non-normal. This theorem's significance lies in its transformative ability. It changes our perception of sample means from just a collection of individual data points into a powerful tool for statistical inference. As the sample size grows, the distribution of sample means takes on the properties of the standard normal distribution. This allows us to use its well-established characteristics, like the 68-95-99-7 rule, to make informed inferences about the population mean. This statistical principle empowers us to draw conclusions about the overall population, even when we have only observed a small part of it. The central limit theorem also forms the theoretical foundation for many statistical tests that rely on the assumption of normality. These tests, such as the t-test and z-test, are frequently used to evaluate hypotheses about population parameters, like the mean or proportion. The central limit theorem's assurance that sample means from sufficiently large samples approximate a normal distribution validates these tests' use, even when the actual population distribution is unknown or deviates from normality. In a nutshell, the central limit theorem is a cornerstone of statistical inference. It allows us to draw inferences about a population from a limited sample. It applies to various population distributions, including non-normal ones, and its implications for statistical tests highlight its importance in statistical analysis and scientific inquiry. As we deal with complex data sets, the central limit theorem reminds us that even with limited information, we can make informed judgments about the broader population. This is all thanks to this remarkable statistical principle.